Mr. Yasmina, your pre-calculus professor discussed vectors. Okay, so a lot of this will be reviewed. So what is a vector? Don't ask the biologist what a vector is, please.
It's a line.
Huh?
A line.
A line.
It's
a vector.
And direction. As a physics.
It has a start and end point.
So the vector is a quantity that has two attributes.
Magnitude. Direction.
Excuse me. Magnitude and direction. So what are some examples of vectors?
You can use cardinal direction.
What are some examples of vectors? How about temperature?
Scaling.
Temperature, vector or scale? Temperature. Why is it a scalar? Because it's just how hot, 20 degrees, 30 degrees, doesn't tell you 20 degrees in direction. How about work or energy?
Oh, that's hard.
Work or energy is a vector? Who says a vector? Who says a scalar?
Work itself is.
Who doesn't know? A scalar.
Oh, yeah. Work by itself. Right.
Energy. What do you mean by work energy? Gasoline.
Joules.
Oh.
10 gallons of gasoline to burn this. 15 gallons of gasoline to burn that. 15 calories to burn this.
Calories or joules.
20 calories to burn this. There's no direction.
Isn't a calorie 1,000 joules?
Anything? Who wants to give me a vector?
Gravity.
Huh?
Gravity.
Gravity. Yes, because it is a
Magnitude and direction.
F O R forces. There are all kinds of forces. Forces. All kinds of forces. Electromagnetic forces, gravitational forces, all kinds of forces. What else? Velocity. Why? How about speed?
No.
Why not? Because speed is just magnitude. You say 20 miles per hour in the direction of Atlanta, or 20 miles per hour in the direction of Clemson. If you're going to the game in Atlanta and you're driving to Clemson, you're in the wrong direction.
Acceleration.
Acceleration. Okay, now please do not ask the biologist what a vector is. They don't know. Okay? They say, you say, well, give me an example of a vector, they say fly. Right? There we go. The vector that sets a fly. So please don't ask your biologist, give me an example of a vector. Okay? They will say sets a fly. Sets a fly is not a mathematical vector. I don't know what they mean by sets a fly is a vector, but they are using it in a different context, okay? You can go and read it up. Yeah, the vector control and whatnot. They're trying to make it mathematical vector and control theory. Then you go to mathematical terms in one word, in one phrase. They're probably using it in a different context. Clear? Okay, now let us quantify these things. Okay? Mr. Collas, you like that joke? Okay, let us talk about how we quantify vectors, okay? Now, I'm going to do two ways. I'm going to do the geometric way. The geometric way is the way the physicists do it, and it helps motivate us to do the algebra. The physicists really know what they're doing when they talk about vectors. And they say, well, you know, if you want to manipulate vectors, this is the way to do it. Then you say to yourself, now how do I do that algebraically? So let's talk about the geometry of vectors. It should be very quick. So here's a vector. Give me a name for a vector. Give me a vector. Here's another one. What do you want to call this vector? Vector A, not bad. Okay. How about you?
I
Now-
don't want you, I wanted A.
Okay. Now, what happens if I want the components? What do you want to call the components? Yeah, well, you see. I prefer to call it vector U and then give the components A, B, C. But I've been doing this for 20 years, so. Okay, U, and this one? Huh? V. Now, if you're going to read your book, it's going to be quite different. I have no idea what it's like in your book. Okay? Who's got the book here? Let me see. Oh, they use U's and V's, Miss Christina.
I don't like using
Push
V's.
my disc.
I'm sorry, what can I
They're
do?
not nice. They bother my OCD.
Get out of your comfort zone.
Right.
So here are vectors. This is a vector, and this is a vector. Now, you can imagine me, poor Dr. J, having to deal with that thing. This is probably going to mess with Christina. Okay. What I have to do,
He's making it bold, because that's how you do vectors.
yes. Now, what if I have to do 20 vectors? I'm not going to bold. What do I do, Mr. Michael?
Use it
Put
as
an arrow on top. Okay? Now, I'm sure that's going to mess with their head. Miss Christina, that's going to mess with your head. But the fact that they're using bold letters in your book and Dr. J is putting arrows on the top,
Yes.
what would you like me to do? Use bold? I'm not.
We use
Sorry.
a different color.
I'm not going to use bold.
How about we just ask for a different color to signify bold?
I'm not, huh? Oh, so we're going to say bold you. Bold you.
No, we just use a different color, like blue or purple
But you know
or
Dr. J
green.
uses blue, red, green, purple all the time, right? I want to use this, okay? You?
Well, you did say physicists.
Huh?
That's pretty nice.
Well, what can I do? No, I can't. Damned if I do and damned if I don't for you, whatever I do. So, now, who can tell me what is the relation between these two vectors?
They're the same.
They are the same. Okay, so the fact that the vector is here over here, because vectors have got nothing to do with position. Okay, the vectors have got nothing to do with position. These are the same vector. The same. Anyway, so here are two vectors, u and vector v. What can we say about u and v? They have the same direction.
It's greater magnitude.
And here's another vector, u, and here's another vector, v. What can we say about these two vectors? They have the same magnitude. Now, we need to do what physicists do with vectors. What are some of the things physicists do with vectors? Or other people? Huh? Before they add them, what do they do? They stress them or shrink them. Huh? We call it scaling a vector. Scaling a vector. Scale multiplication of vectors. So here's a vector, u, and that is v. And that is 2u. Now you take a vector and you scale it, you obtain what? You take a vector and you scale it, you obtain what? A vector. Clear. So this is an operation on vectors to obtain a vector. Scalar multiplication of vectors, that is to say, take one vector and multiply it by a scalar and obtain a new vector. You take a vector u and multiply it by a half, you will get a vector in the same direction, but scale is shrunk. Take a vector and multiply it by 2, you will get a vector in the same direction, but twice the magnitude. So this is called scalar multiplication. Take a vector and multiply the scalar. Well, this is geometry. This is geometry. What else do physicists do with vectors? They add them up. They add them up. Now, when physicists add vectors, they know what they are doing, trust me. Then they say to a mathematician, do you know what is addition? What does the mathematician say? Well, now, if you are going to add things, you better do it correctly. That is to say, if you add 2 plus 3, it better be the same as 3 plus 2. You would like that commutativity. If you add 2 plus 3 plus 5, you can add the 2 plus 3, get the 5, and then add it to the 5. Or you can add the 3 plus 5, and then add it to the 2. That is to say, if you add a vector u plus v plus w, you better be able to add the u plus v, get a vector,